Welcome to Ashutosh Academy. I welcome you to this new episode on L Hospital Rule, part 2, methods of fuller limits. From my previous video, I would like to tell you something, that we were differentiating the functions. Okay. To know more about this video, you'll have to watch my previous video on L Hospital Rule, part 1. In that, I told you that the function is again and again differentiated. Okay. We follow this method till the time we remove 0 by 0 format. We have to remove this, or we remove this format, anything. It was like etc. There were many points that I made in my previous video. So it's gonna be we're gonna differentiate the function again and again till the time we obviously I'm talking about this also simultaneously because both of them are involved in the question. Okay. So you need to remove this whole thing. Okay. Let's take some examples. You'll clear your concepts more. So this is the first question that I have taken here, is limit x tends to 0, this whole function. So how are you going to calculate this? You put x equal to 0 in this whole question. You'll find 1 0, okay, into log of again 0, sin 0 is 0, log of 0 is again what? Infinity. It can't be solved. Okay, this is the format. And if you convert the question, because this is convertible. How? Let's see. You convert the function like this. You take the function as this whole 1 by x. Now you'll find the numerator is coming out to be infinity, and the denominator 1 upon 0 is infinity, is again infinity. So finally you've got this form. You can solve the question now because you made it in the format that we can apply the L Hospital rule here. Applying L Hospital rule here. Okay, apply L Hospital. You don't need to calculate differentiability, continuity again and again, because it's in these kind of questions it's quite clear that the function is differentiable and all. Let's directly write the value by using L Hospital rule. Just copy the question again, okay, and not the question, just copy the limits, and what you do here is differentiate this whole numerator and denominator individually and write it down. When you differentiate log of sin x, you'll get what? What is the differentiation of log of sin x? Sin x is, I hope you know differentiation, then only you will be able to solve limits. Okay, so 1 divided by sin x into sin x differentiation is cos x, okay, whole divided by, what is differentiation of 1 by x? Is minus 1 by x square. So minus 1 here and x square here. Okay, this is the given format that you've got. So now you can write it as like this: limit x tends to 0 minus of cot x divided by 1 by x square. As you can see, I am again and again keeping x below only, not taking it in the numerator, because 0 into infinity format will come. We need to avoid that. Now solving it further, limit x tends to 0 minus of x square, minus of x square whole divided by, it's not minus of minus, it's just single minus. This is my mistake of writing it wrong. I'm removing it from, okay, so that you can understand. So we've got minus of x square divided by sin x. Now you can again put the value as x tends to 0, 0 upon 0 is again 0 format. But we can solve this further by using limits properties. Watch my limits properties video, you'll get to know more better. Minus of x here and x divided by tan x. Okay, now this is again 0 by 0 format, but there's a formula when the limit tends to 0, x upon tan x or tan x upon x, it's going to become 1. So minus of this quantity is 0 into 1, this whole quantity is 1. or if you don't know how it's becoming 1, just differentiate again by using an hospital rule. I can tell you, let's understand from this step here. It says limit, not from this, from the previous step, okay? Limit x tends to 0 minus of 2x, just differentiating this format, okay? For tan x differentiation is secant square x. Okay, now you put x tends to 0, this becomes again 0, and this becomes 1 upon cos 0 sin it to 1, this quantity becomes 1. So now it's following 0 upon 1 format, 0 upon 1, sorry, not infinity. So this is valid in mathematics. The denominator can be moved 1. So the answer is minus of 0 into 1, and the whole quantity comes out to be 0. And remember, 0 can be written as log e of 1. Okay, log 1 is 0 only. So this is our answer. I guess you found it easy. And if you don't know the limits properties, then also it's okay. You can apply L'Hospital rule anywhere and you can solve the given question. I'll take more examples now. Let's look at this question. I find it very interesting. Okay, so as you can see, it's given that when you put the limit x tends to 0 in this question, you'll find it as a finite quantity. That means it's not following 0 upon 0 format. When the answer will come, it will not be 0 upon 0 format or infinity upon infinity format. It can be something like this. It can be a number, any number. It's a finite quantity then. Okay, and you are asked to find out this value. So how are you going to do it? It's very simple. Okay, let's solve it. It's very easy. First you put the value x equals to 0 in the whole question. You'll find numerator and denominator, okay, becoming cos 0 0 is 1 plus a, okay, cos 0 is 1 plus b whole to the power 0. Now the question says it should be finite. So before becoming finite, it should be 0 upon 0 format. Then only you can differentiate it further. That means the numerator has to become 0. This is only valid. I can see, I can like tell you here is, this is only valid if it is 0 upon 0 format. Okay, then only you can apply L'Hospital rule. Okay, so it comes out from here. We can derive it as like this: 1 plus a plus b coming out to be 0. This is our first equation. Okay, let's solving it further. Now what is the next step? Apply L'Hospital rule now. Apply L'Hospital. Why can we apply now the L'Hospital rule? Because we've assumed that numerator has become 0 and denominator was already 0. 0 by 0 format we've got, and now we can apply L'Hospital rule. Apply it, you find limit x tends to 0 minus 4 of, just simply differentiating, you'll find this. Okay, now you can again put x equal to 0 in the question. You'll find 0 upon 0, not 0 upon 0. You'll find numerator upon denominator to be 0 by 0 form. You can check. Okay, 0 into 0. Okay, this quantity becomes 0. This is also 0 into a 0. This also becomes 0. Again apply L'Hospital. Why we can apply again? L'Hospital rule can be applied till the time we don't remove 0 by 0 format or infinity upon infinity format. So you'll find limit x tends to 0 minus 4 was already there, cos 4x into 4 minus 2a to cos 2x into 2 whole to the divided by 12x squared. Now if you put x here as if you put at x tends to 0, you'll find the numerator becoming this. You can put it, numerator will be this, okay, because cos 0 is 1. So minus 4 4 16 minus 2 2s are 4a is becoming 1 upon 0. again you should follow from L hospital rule that 0 by 0 form is to be made here, to be made again. You need to make it as 0 by 0 format. So once you make it again, you assume that numerator is 0, so this becomes equal to 0. So we can say that A is coming out to be this value. You've got the value of A. Now put this value in the previous answer that you got from above, A equal to -4, and you'll find B coming out to be 3. This is the method that you follow. Okay. Thanks for watching, and please subscribe to my channel Ashutosh Academy, and see my other videos. There is a part 3 video coming up for other numerical problems on L hospital rule.